And here we go, part two of texture mapping. So we left off here pointing out, yes, you can transform um, the texture coordinates. I actually do occasionally have a use for doing the angle. And it's funny how it comes about because it usually comes about because somebody held their camera crooked when they took a picture. And so the image is not perfectly horizontal vertical, it's off at a little bit of an angle. Well, rather than kill yourself retaking that photo, what you can do is just rotate the texture coordinate like +2 degrees, -2 degrees. You kind of play with it till it looks good. And that's how you handle a cockeyed image. So yeah, you can do that with texture transforms. Okay, but part two of the texture notes starts here. Texture objects. The texture image 2D function doesn't actually use the texture. What it does is it downloads it from the CPU to the GPU, and it makes it the current texture. So sort of like GL Color 3F gives you a current color, um, the transformations give you a current transformation. GL Text Image 2D gives you a current texture. Now, I find this really funny. The original OpenGL only let you do this. That is, there was one current texture. If you wanted to have two textures active, well, they assumed you wouldn't. They assumed you'd only ever have one texture active. Like, oh my God, what were you thinking? But if you had two textures you wanted to be active, you would have to call text image 2D with the first texture, use it, then call text image 2D with the second texture, use it. Then when you call display the next time, you have to call text image 2D on the first texture, use it, texture image 2D on the second texture, use it. And so what you were doing was downloading each texture over and over and over again, even though it's the same texture each time. So, that was sort of crazy. So it didn't take the OpenGL world very long to say, you know what, we need a way of storing our texture images in the GPU and then just simply use them after the next time without having to load them more than once. That's called texture objects. And in OpenGL, anytime you see the word object, it's unfortunate they used it because we use it to mean something else in C++, Java, and so on. But anytime you see the word object, it means something's being stored on the GPU. Display lists, if this had happened earlier, would have been called display objects. They should have been called display objects. But anyway, texture objects means you can store textures on the GPU and then simply call them up, just like we do with display lists. So here's what happens. In init graphics, let's say we've got two textures. Here's what we're going to do. We're going to call BMP to texture on one, which just brings it into a CPU array. Call BMP to texture on the other. Cool. We're going to generate texture ID numbers. This is just like generating display list ID numbers. You don't care what the actual number is. All you care is that it's unique. Now you're going to say something called bind texture. And what bind texture does is it makes it the current texture as far as your program's concerned. So now text 0 is the current texture, and let's go fill it. Okay, let's fill it with these parameters. Let's fill it with this array. So now that texture area over in GPU memory has all this information in it. It has the wrapping parameters, the interpolation parameters, and the actual texels, the RGB texels in GPU memory. And anytime we repeat the phrase bind that, it just makes it the current texture. Now we do it again. We're going to say bind text1. That now makes its area in GPU memory current. We're going to set up the parameters for texture 1. We're going to bring in the RGBs for texture 1. Okay, we now have two spots in GPU memory and each texture is in its own spot. And so now think of that as being like a switch. There's a switch, and I can throw the switch between the two textures. And that's really all it takes. Now when I say bind texture, that's throwing the switch up here to texture 0. When I say bind texture 1, that's throwing the switch down here to texture 1. So it's very fast to switch between textures. Nothing gets downloaded. The download's already happened. Yeah, in some ways this is very much like doing display lists. You do have to tell it how to use the texture, which is typically either replace or modulate. But other than that, you don't have to repeat any texture information. It's already there. So this is great. Now, what does binding actually mean? OpenGL has a context or a state, and the state is all the current stuff. Current color, current transformation, current lighting information, and there's also current texture. So when you say bind, essentially, we're taking the information in GPU memory about that texture and making it part of the state. So now anytime OpenGL uses a texture, it's going to be using this one. And if you bind a different texture, well, it's like a different spaceship docks to the context or the state. If it was up to me, I would have called it docking, just because I like the sort of Star Trek metaphor. But it's not, it's called binding. Nobody asked me. I wanted to put this out there. Of course, you watch movies now, and there's texturing just everywhere. Games, texturing everywhere. But I have a special spot in my heart for these because these were the first. All three of these, Aladdin, Beauty and the Beast, Tarzan, whoops, they were hand-drawn animation movies, but they each movie had some special feature in it that they wanted to make it so special. They made this exception and did texture mapping on it. And so in Aladdin, it was the carpet. They wanted this pattern, but they knew they couldn't animate the pattern. So they did texture mapping and animated the vertices in the texture, and the pattern came with it. For Beauty and the Beast, they used textures all over the ballroom scene. The ballroom scene is really the transformation moment in the movie. Okay, that's not a spoiler. If you haven't seen it by now, it's your own fault. But they use textures all through that to make it special, to make it obviously different than the hand-drawn. And in the animated movie Tarzan, they didn't want Tarzan as a chest-thumping guy. They wanted him more as an X Games guy. And so they wanted him skimming through the trees, but they knew they couldn't really move through the trees and get the perspective right drawing by hand. So they did the trees, they did the branches in computer graphics and put tree growth texture on them. And then they filmed moving through the computer graphics branches and then animated the Tarzan skimming along on top of it. So yeah, these are older examples, but they're special to me because suddenly people realized that texturing could be part of the storytelling. Okay. Now, of course, now everybody's using texturing. Jungle Book, in Jungle Book, he's the only thing that's not a texture. He acted on a soundstage, an empty soundstage. Everything else, the foliage, the animals, the water, that was all computer graphics, 100% textures. Zootopia, lots of textures. The Pixar movies, lots of textures. Lion King, like everything was computer graphics in Lion King. Every bush, every rock. Anyway, very cool. Also, textures can be done with equations. So really, most of the time, and in this course, in 450 and 550, we're going to load texture images. In the shaders course, we'll talk about doing it with equations. And I'll make a video of this. We'll have a video of this for looking at procedural textures. But Okay, what is this? Well, it's the topography of Oregon. Yay, there's the Cascades and all of that, the Columbia River, the Willamette Valley. Cool. With all the heights. And so you're tempted to think that that's a million triangles to make those heights. But how much geometry is in this scene? One quadrilateral. This is one quadrilateral. The appearance of heights are a programming trick using equations and shaders. Okay, so you can do that sort of thing. And you can also do things like this, is things like fractals. You can zoom in on the Mandelbrot set and but do it in equations. And so if you load a texture out of an image and you zoom in too much, eventually you run out of resolution and things get real chunky looking. But if you're using an equation, you essentially don't run out of resolution. You do run out of floating point precision in this case especially. Um, but you don't run out of resolution because there isn't a texture image. So textures are even more flexible than how we're going to use them this quarter. But I just wanted you to know that there's actually more to it.